In this video, I'm going to introduce you to Acronix's Congestion Map tool in the ACE software. Congestion Map is currently a hidden preview feature of the ACE floor planner used to visualize routing congestion in a routed design to help identify and alleviate routing congestion issues. Functionality of the tool is still under development, and additional features and usability improvements are being added constantly. Before learning about the congestion map, it's important that you already have a basic understanding of the ACE FPGA design software, and especially the floor planner. If you need to learn more about Acronix tools, visit the training video site on acronix.com. I especially recommend viewing the ACE Place and Route tutorial, which includes a section on the basics of the floor planner, which let users view the actual placement and routing of the design. The congestion map tool can be enabled as a layer in the floor planner view. In this training, you will learn how the congestion map can be leveraged to solve routing issues in your design. You will also learn the steps required to collect, visualize, and interpret the routing congestion data in the congestion map to help you accomplish your goals. The congestion map tool is a feature of the floor planner that lets you visualize and analyze routing congestion for your design. Usage of the tool involves three phases: data collection, data visualization, and result interpretation. In the first phase, routing congestion data is collected. This is done if the router save congestion map implementation option is set to 1 prior to running the router. Once the option is set, you can run the router as part of the synthesis place and route flow from the beginning, or if placement has already been run, you can restore the implementation from the placed ACXDB file and then run or rerun just the router portion of the compilation flow. In the second phase, to visualize the congestion data, you'll need to send the congestion data to the GUI by either restoring the routed ACXDB file or use the report congestion-show in GUI command. Once the data is loaded, go to the floor planner view, expand the file panel, and turn on one of the congestion map views to visualize the results. The third phase is the results interpretation phase. Here, the user gains insight by examining congestion of various resource types across congestion iterations. The user can also combine non-clock net visibility with the congestion map to see the nets that contributes most to routing congestion. Understanding the nets that cause congestion is the first step to solving routing congestion issues. Next, I will demo the congestion map through the three phases. Alright, the first step in using the congestion map is to collect congestion data in the router portion of the compilation process. I'm going to run ACE in batch mode to collect the data. Of course, this can be done in the GUI as well. Alright, in ACE, I will now open my ACE project by using the load project command. Alright, once the project is loaded, I'm going to restore my placed ACXDB. The congestion data is collected during a router portion of the flow. If you've already performed placement, as I have, you can simply restore the post-placement ACXDB with the restored info command. Now that's completed. Next, we need to turn on the implementation option to collect the congestion map data. We'll need to set the router save congestion map options to 1. And it's important to run this step after you restore implementation step, as restore info will override options with those saved in the ACXDB file. And now we are ready to run or rerun the router. This step can take a little bit of time. All right, so once that the congestion data is collected, we can now run ACE in the GUI mode. To view the congestion data in the floor planner, I'll need to run ACE in the GUI mode. In ACE versions prior to 10.6, when significant memory utilization optimizations were made, the memory footprint of the congestion map may exceed the maximum heap memory for the ACE GUI. Using the -vmargs-xmx command increases the memory limit. Next, with the project loaded, we need to send the congestion data to the GUI. If you run the router in another session, the easiest way is to restore the routed ACXDB file, and congestion data from all router iterations will be sent to the floor planner GUI. You can also use the report congestion-showing GUI command to send data from a specific iteration to the GUI, but this is unnecessary here as I'm already restoring the routed ACXDB file. Now that the data is ready to be visualized, we can go to the floor planner perspective. Expand the layers group to see the congestion map options. First, you'll need to choose a resource type for which the congestion data should be displayed as colored tile overlay. I'll first take a look at the switchbox congestion. Switchboxes are routing junctions for outgoing wires to other tiles. Input XBAR is the crossbar that connects routing tracks to logic inputs in the tile, while output XBAR is the crossbar that connects logic outputs in the tile to routing tracks leaving the tile. In each tile, for switchbox, the colored triangle within each tile represents the total usage of routing wires in a specific direction. For example, triangles on the left represent westbound routing usage, while the triangle on the right represent eastbound routing usage. When switchbox is the resource chosen, you have the option to select a specific type of routing resource to visualize. The routing resources are categorized by length in number of tiles. You may also choose the combined length to show combined congestion for all wire types. With the iteration pull-down, you can select the data from the exact router iteration. Router iterations are the passes the router makes when trying to achieve a legal route. Sometimes it's helpful to examine earlier iterations rather than a final iteration to determine the problematic congested areas. You can use your scroll button to scroll through the iterations easily. Here you can see as we progress through the iterations, the routing congestion gets better and better. You can also choose what the colors represent. With demand supply ratio, this is simply the demand versus supply for the chosen crossbar type. Blue is 0, 1 to 49 are shades of green, 50 to 99 are shades of yellow, and red denotes routing demand is greater than supply. When overflow heat map is chosen, the amount of overflows will determine shading. Blue is 0 demand, green is no overflow, while yellow through red denotes degree of overflow from 1 to overflow being greater than supply. With the overflow heat map, you can see as we go through the iterations that there is less and less overflows. Finally, to examine and understand the problematic nets that contribute to routing congestion, it may be helpful to also turn on non-clock net visibility in the layers. This is especially true for tiles with red indicating congestion. Select all the nets that crosses the edge of the tile and examine the nets for length and destination for deeper understanding. You can choose to see the properties for each net as well. Zoom out and you will see how far the selected nets from a single tile can reach. To summarize, you should now understand the features of the Congestion Map tool, the steps required to enable the Congestion Map in the floor planner, and how it can be used to solve your routing congestion problems. If you need more details, please visit the support portal at support.acronics.com or email support@acronics.com. Thanks for viewing this training.